Hello friends, welcome to Shiksharthi. In this video, we'll be talking about mixtures. So let's start. So this is the continuation video of the first video that we had done on mixtures, wherein we were talking about the removal and addition in mixtures and from mixtures. So we had already talked about, now out of these 4 cases, we had already talked about these 2 cases. In this video, we'll be talking about case C and case D. Right? Okay. Now what is case C? In case C, what we are doing is, first we are removing the volume of the mixture, a certain volume of the mixture, and thereafter we are adding either of the ingredients originally present in the mixture. Followed by the last case in which we are adding either of the mixtures. Now when I say either of the ingredients, so if the original ingredients were milk and water, first we'll be adding either milk or water, followed by water or milk, and then followed by removal. So after addition, then we'll be removing the mixture, and then we'll see how does the concentration and the volume get affected because of this removal or addition. Okay. Just to revise quickly, so we talked about removal only. Removal only means the volume changes, but the concentration of the ingredients originally present in the mixture does not change. Addition only changes the volume also and changes the concentration as well. We had talked about these 2 cases. Third case, so we are removing the mixture first, followed by adding either of the ingredients originally present. Okay, so in this case, what I am assuming here is, let us say, in the original question that I had taken a 100 liter solution of milk and water in the ratio 3:2. What are we doing now? We are removing first and then we are adding. So if 20 liters of the mixture is removed and then 20 liters of either milk or water is added, then what is going to happen? Okay. So now we know already that only removal does not change the concentration of the liquids originally present or the ingredients originally present, but it changes the volume. So here, if I talk about, we would have started off with 100 liters and then V1. V1 is the first change which is happening, the first step, the first operation. In which now when 20 liters is removed, naturally 80 liters, we are left with 80 liters only, but the ratio after the first operation, which is removal, remains the same as it was earlier, which is 3:2. So can we say, or should we say, that M is to W is the same as M1 is to W1? We should. Now we were talking about the proportional constant. So you will see that when the volume changes, despite the fact that the ratio remains the same in this case, but the proportional constant changes. So when I say the proportional constant changes, now 20 liters here is equal to 1.25x. And originally if I see, 20 liters was how much? 1x or 1 part. So a point or a lesson to be learnt here is, when the volume increases or decreases, the value of the proportional constant also changes. Right? Okay. So now when we are adding 20 liters of the mixture, so we know that 20 liters is equal to how much? 1.25x. So in the first case, we are adding only milk to it. So in that case, this will be 3x plus 1.25x is to 2x, because the volume by parts of water remains the same because we are adding milk only. So in that case, this ratio comes out to be 4.25x is to 2x, and the simplest ratio you can calculate, and it works out to be as 17:8. So if I say, now what is the inference here? The inference here is, when I remove the mixture, when I remove the contents of the mixture and then I add something to the mixture, the volume, finally, the volume also changes. Can I say the volume finally changes? No. Since I'm removing the same amount of volume and adding thereafter the same amount of volume, the volume remains as it is. Okay. But does the concentration of the liquids change? Does the concentration change? It does change. So here, though I have written that V and C both would change, but this is asterisk to the condition. This is dependent on the condition that I remove some entity and I substitute by entity which is not equal to the removed entity. So in all these four cases can be further subdivided. For example, when I'm removing and adding, I can say here, let's say removal and then addition may be equal, and the removal followed by addition in volume may or may not be equal. As of now, in this video, we are talking about removing, let's say 20 liters and substituting by 20 liters only. Had I removed 20 liters and substituted by 30 liters, the volume finally also would have changed, which is why I've written this thing. Okay, so this is asterisk to the condition that the volume of addition and removal is not the same. Okay, but the concentration in either of the cases, whether I substituted by the same volume or I substituted by a different volume, the concentration in any case is going to change. And why is this changing? Because addition changes the concentration. Right? Okay, the final case here. So in the final case, what are we doing? We are first adding and then we are removing. And we know that addition changes the concentration and the volume both. So anyway, if 20 liters of the mixture of milk and water is added and then 20 liters of the mixture is removed, so we know that M/W originally was 3:2. Now here the first addition, the first operation here is adding, and we know that here the proportional constant is how much? 1x, which is equal to 20 liters. So in the first case we are adding milk only. So when we are adding milk only, this becomes how much? This becomes 3x plus x is to 2x, and the final ratio comes out to be 2:1, and the volume thereafter, since I'm adding, changes to 120 liters. But now if I remove, when I'm removing finally, removing how much? I'm removing 20 liters only. So we know that after removal does not affect the concentration of the liquids originally present. So after removal, which is the second operation here, the ratio remains the same and the volume comes back to the original. Now here also I have written, so can I say that the concentration of milk has changed? Yes, now it is 2/3 and originally it was 3/5. So here also this is asterisk to the condition. Now what is asterisk to the condition here? We are talking about the volume will definitely change. The concentration definitely will change in both the cases. The concentration of the liquids originally present, but the volume will change dependent on what is the volume that is being removed and it is being substituted by what amount. So if the removal amount is equal to the addition amount, then the volume remains the same. Otherwise, the volume also gets changed. Similarly, we do it for when we are adding water only. Okay, so now please check the answer. So time for inference. Time for inference is, in the first case, we started off with 3:2 removal only. The ratio 3:2 remains the same. In the second case, we were adding only. So we started off with a ratio of 3:2, but finally we got a ratio of 2:1 and 1:1. In either of the cases, the ratio changed from a 3:2 to either 2:1 or from a 3:2 to 1:1. In the third case, okay, what is the final ratio that we are getting? We are getting the ratio as 17:8 and 12:13. In any case, the ratio does not remain the same, which signifies what? The concentration of the liquids definitely would have changed. Right? The contents of the volume, whether they change or not, are dependent on the substitution amount and the removal amount being the same or unequal. In the last case also, we see that we started off with a ratio of 3:2, but then when we talk about adding first and then followed by removal, in any case the ratio gets changed. Now please mark, in all these cases the ratio gets changed and it is just because of addition, because something that is common to case B, C and D is addition. I hope you will be able to take your own examples here and practice. It is very easy to practice. Don't wait for questions. You can take the same set of examples or you can take your own examples once you have understood the concepts, and then you can always take it to a next level. So what is the next level that you can take it to? So last time we were talking about that we can also substitute it by a mixture. As of now, we were only adding milk only or water only. We could have substituted it by another mixture. For example, one ratio of milk and water was 3:2, and that could have been substituted by another mixture of milk and water in the ratio 2:3. So maybe we do it in the next video. Next video on mixtures and maybe on allegations. So if you think that something very knowledgeable has been discussed today, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you start receiving updates from us regularly. If you want us to do some specific videos on specific topics, please comment in the comment section. Thank you so much. Until next time we meet, goodbye.